So we are going to learn the topic discrete random variables. So under discrete random variables, we need to know what discrete means and what a random variable means. So discrete means not continuous, like data can be divided into two parts, can either be discrete or continuous. And as you already know, discrete data are like the data values that can take specific values only. So the number of people, for example, can only be like 10, 11, 12. It can't be like 10.5. Just because a person is small, you don't say it's 10.5 people. Also shoe sizes can be discrete, for example 5.5, 5 and 6, and it can be decimal values. It's okay, it's not always whole number values, but only specific values within a range. Continuous values, however, are values that can continue, in the sense they can take any value within a given range. For example, if you say from 10 to 15, there are infinite number of values, 10, 10.1, 10.11, 10.12, all those values within the range are counted for continuous values. But right now we are only talking about discrete values, that means only specific values within a given range. A random variable basically is something like an outcome that is possible. So there are several possible outcomes out of an experiment, so the possible outcomes are called random variables. So let's scroll down and one more time look at it. Like variables means values that can change. So the outcome of an experiment, that variable is called a random variable, right? So you just need to remember these important words. The all possible outcomes of an experiment is also called sample space under probability, and the sample space and a random variable are quite similar, because a random variable is basically an outcome, and all possible outcomes is called the sample space. So roughly, yeah, that is it. And then we can scroll down. Just give me backspace because I just drew a line here, right? No, it's fine. Yeah. So we need to understand what a random variable is. So let's read through the examples. Example 1 here says a coin is tossed 6 times and the number of heads x is noted. Write down all possible values of x. So the possible values of x means the possible outcome. So what is the event? It says understand what x is. It's the number of heads. Therefore, the number of heads, if you toss it 6 times, it can be any number starting from no heads up to all 6 heads. Like when you toss a coin 6 times, you can get 0 heads, and that means all tails, or you can get 1 head and the rest tails, or you can get all heads. All these possibilities are valid. So you should also be able to realize what discrete random variables are and what continuous variables are. But discrete variables means values that can only take whole number values. Variables that can only take whole number values. So let's first look at this thing called a probability distribution. This table right here is called a probability distribution. This is called a probability distribution because x right here gives you all possibilities, all the possible values. This is called all possibilities. And these are the corresponding probabilities. The probability of getting 1 is given here. Probability of getting 2 is given here. Probability of getting 3 is given here. Because these are all the possibilities, the probability, the addition of all probabilities, is equal to 1. As you already know, when you add all the probabilities possible, it should add up to 1. And now if I ask you that there are 3 fair coins tossed, 3 fair coins are tossed. That means 3 fair coins means getting heads and tails are fair, or else even, equal. The number of heads is x. Write down the sample space. The sample space is the possible outcomes. So you can either get 3 heads or 2 heads and 1 tail. You can change the order of it, and these are the possible outcomes. You can get tail, 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 head. You can check the outcomes. Is that? I hope that is clear. You can first get heads, then you can get heads, then you can get heads. right? Also, you can get these outcomes by looking at a tree diagram. First, heads and tails, again heads and tails, again heads and tails. So if you keep drawing this whole tree diagram, if you go the first pathway, start from here and go this way, you get HHH. If you go this way, you get HHT. If you go this way, you get HTH. Like that, if you go along these pathways, you will get all these possible outcomes. The probability distribution would be the number of heads. See, the number of heads is x. That means the number of x can either be 0, 1, 2 or 3. The probability of getting 0 heads would be not getting heads 3 times. That means getting tails. The first time getting tails would be half. Next time getting tails, again half. The third time getting tails, again half. Multiply these 3, the answer is 1 over 8. Then the probability of getting one head. One head means this event right here, this event right here, and this event right here. Each of these events has a probability of half times half times half, 1 over 8. That can happen 3 times, 1 over 8 plus 1 over 8 plus 1 over 8, which is 3 over 8. Just like that, you can find these probabilities. You can even write it as a function. A probability function means writing it with equations instead of drawing this table. So here, this notation you need to study. This is something to study. To say the possibilities of x and the corresponding probabilities. For example, x can take the values 0 and 3. At that point, the probability is 1 over 8. X can take the values 1 and 2. At that point, the probability is 3 over 8. If not, if x takes any other value, the probability is 0 because the probability doesn't exist for those values. Only the probability exists for these 4 values. So you only say for these 2, the probability value is 3 over 8. That's what's written here. For the first and the last, the probability value is 1 over 8. So that's what's written here. This refers to the first and the last. I know it looks complicated, but yeah, it won't be too difficult to understand, I think, if you look at this. Oops, I don't know how to erase this here. So if you look through this slowly, it will become clearer. So one more time about the probability function. And I'll do a few examples so that you understand this better. So yes, the addition of all probabilities is 1 is also very important to understand, because all possibilities are given. What is the probability of each event? So let's look at a question itself to try to understand this. I would like to do question number 4. Here it says a discrete random variable x has the following probability distribution. This gives all possibilities of x here. This part is all possibilities of x. This is the corresponding probabilities. The addition of all probabilities is supposed to be 1. That means 1 over 3 plus 1 over 3 plus k plus 1 over 4 is equal to 1. From that, you can figure out what this value of k is. When you take off 1 over 3 plus 1 over 3 from 1, you get 1 over 3 as well here. 1 over 3 minus 1 over 4 gives k equals 1 over 12. And here the same thing is given in terms of equations for the rest of the question. So let me do one from here. This one also is given as a probability function. It says when x is 1, 2, 3, 4, the probability is k times x. Show that k is 1 over 10. What this means is, if you draw a probability distribution like this, if this is x, these are the probability values. So 1, 2, 3, 4 are the possibilities. So those are the only possibilities, because those are the only values of x that are given here. So kx means you substitute 1 here into kx to get the probability when x is 1. That is k. Here it is 2k, because 2 times x. 3 times x, 3 times k and 4 times k. The addition of all of this is 10k. The addition of the total probability is equal to 1, so k is equal to 1 over 10. And we got the answer already. Here there is another function. Since this function is similar to this fifth one, I am going to skip that and do the seventh. I am going to draw another probability distribution here also to get the value of k. As I can see, there are 4 values for x. Can be 1, 2, 3 or 4. When x is 1, I am supposed to use this equation. Substitute x equals 1 here, I get k. Substitute x equals 2 into this equation. 2 here, then you get 2 minus 1 times k, that's also k. Substitute 3 into the first equation, you get 3k. Substitute 4 into the second equation, you get 3k as well. Now when you simplify to get the value of k, you get the addition of this whole thing as 8k equals 1, k equals 1 over 8. Construct a table giving the probability distribution of x. Now you are supposed to construct a table. So now let me erase this and write the correct values now, because like after substituting k. So then here I get here I got k, so that this is 1 over 8. It was k here, so this is 1 over 8. This was 3k, so this is 3 over 8. This was also 3k, so 3 over 8. And then let's also focus on one more question here. The eighth one says the probability distribution. The probability distribution can be drawn here. There's several values here for x and the probability. So minus 2, minus 1, 0, 1 and 2. Substitute minus 2 here. So no need to substitute. When x is minus 2, straight away the probability is 0.1. When x is minus 1, the probability is also 0.1. When x is 0, the probability is beta. We don't know the value. When x is 1, the probability is beta again. When x is 2, the probability is 0.2. So you get 2 beta plus 0.4 equals 1. The addition of all probabilities add up to 1. Beta is equal to 0.1 minus 0.4 divided by 2, that's 0.3. Now construct a table, that means replace this beta with 0.3. So here you write 0.3, here also you write 0.3. That's it. It's quite easy, the first exercise, right?